Speaking of MyMathLab though, you need to be very careful when you're typing your answers into MyMathLab. If you make even one miskey, it will count your problem wrong, which especially as a warning on this test for test 2, any of the problems with exponents, I would make sure that you're showing your work on your scratch paper so that when you send it to me, I can catch any miskeys or typos. And that also means that the grade you get at the end of test 2 may be lower than it actually is. So remember, I do go back, take your scratch paper, give partial credit, that sort of thing. So your grade may end up popping much lower than you expect. Wait a week or so. I will go through your scratch paper, assign partial credit. That may make a huge difference. Try not to panic because miskeys on this will throw off a lot of your homework and your test grades. But at least with the homework, you can do things multiple times and get your grade so that it's pretty close to perfect. With the test, you've kind of got one shot, and that's why I go back through them. So don't panic if you get a grade that you don't feel was quite right. Just send me your scratch paper, and we'll work on that with partial credit. Here's another one. In E, we've got 4 to the 5th over 4 to the negative 2nd. So the negative exponent here, there's only one of them is on the bottom. So we're only going to move the piece with the negative exponent. That means the 4 to the 5th is going to stay where it is. Only the 4 to the negative 2nd is going to move up with it. And when we do, its exponent, which was negative, is going to become positive. So now it's up on top. Now we've got two things side by side that are getting multiplied. Remember, when we're multiplying, we've got two bases of 4 here. Remember, even though they're numbers, the base stays the same, so it will stay as a 4. And remember, when we're multiplying, we do what to the exponents? We add them. So 5 plus 2 is 7. And remember, the reason why is this is like saying I've got 5 4s and I've got 2 4s, which gives me a total of 7 4s. Now, my guess is they wouldn't want you worrying about plugging this into your calculator, but they may just look and see if they want you to simplify. If they do, remember you do have a scientific calculator, use it. Let's take a look at F. In F, we've got x to the 8th over x to the 12th. Okay, if you use your rules, what you can do is you can say, oh, well, the bases match, so that will stay the same. We've got x's here, so the base will stay the same as an x. And you're going to do what to your exponents? You're going to, well, I'm dividing, so I'm going to subtract them. So be careful, 8 minus 12. Well, 8 minus 12 is actually a negative 4. Well, what do I do with negative exponents? We can't leave them like that. That means we have to drop them to the bottom of a fraction. When we do, the exponent will become positive. So the question becomes, what's out on top is a hidden 1. And that's our final answer. I like the canceling method here for this one, especially because then I don't have to deal with negatives. If I can cancel out a total of 8 x's. So if I cancel out all 8 x's from the top, with 8 out of the 12 will leave me with the 4. Notice the x to the 4 automatically is already on the bottom. I just have to remember that if I canceled everything on top, then there's still the hidden 1. But again, it really doesn't matter. Let's take a look at G. In G, we have x to the 4th over y to the 3rd. What do we notice? The bases don't match. We've got an x on top and a y on the bottom. Guess what? If they don't match up, you can't do anything. So we have to leave this as is. It's already simplified. And they do have some problems like this in the homework, just to make sure that you understand your rules of exponents, that you can only use them if the bases do indeed match up. Continuing along, let's go over what the power rule for exponents would be. Well, to give a quick example, it is if I have, let's say, x to the third that is then squared. Well, if you think about what this means, the fact that you've got something squared means you've got two identical copies. So what that means is I have two of these x cubes multiplied together, two identical copies. Well, remember, once you hit this step, you're back to multiplying means you're going to do what to the exponents? Remember, when you're multiplying, you add exponents, which would give us 3 plus 3 is going to give us x to the 6th. So if you go backwards a little bit, what did we do to the exponents? Well, we had a 3 and a 2. Well, notice we got 6, so they multiplied the exponents. So multiplying the exponents gets us x to the 6th. A good way to remember this is the parentheses you see. Whenever you do see parentheses, you think of distributing, which means you're multiplying something out. So we can end up with some very, very large exponents here when you're multiplying exponents. So when you have a power and you try to raise it to another power, what you're going to always do is multiply your exponents. The other rule that you see along in here is what happens if you've got parentheses. So this means what if I have, let's say, an x, y raised to the third power? Well, what that means is that everything inside of your parentheses needs to get raised to the third power, which means both the x and the y get raised to the third power, getting you x to the third and y to the third. The same thing is true of a fraction. If you have a fraction raised to an exponent, everything on top gets raised to the exponent and everything on the bottom gets raised to the exponent. It's basically the distributive property, but for exponents. So let's take a look at a couple of examples here. Let's start with problem A. Let's start out with we've got parentheses around x to the 5th raised to the 7th. Again, you've got a power raised to another power. So when you take your two powers, the parentheses should be a reminder that you've got to multiply your exponents, which will get us x to the 35th. Like I said, we're going to see some really large exponents. In this first problem, we've got 4x to the 6th that is then squared. This means that we need to take the second power that's on the outside and raise everything to the inside to the second power. So that means we'd first start off by taking the 4 and squaring it, which is a total of 16. Then we'd start by squaring the x to the 6th, which means we're going to multiply those exponents, which will give us x to the 12th. So our final answer is a 16x to the 12th. In problem C, we have a negative 3x to the 7th raised to the 4th power. So, raising something to the 4th power, we're going to start by raising the negative 3 to the 4th power. Again, we have to raise everything inside, but we're going to start with raising the negative 3 to the 4th power, which is a negative 3 times the negative 3 times the negative 3 times the negative 3. Well, notice that the first two negative 3's when multiplied together will get us a positive 9. And the second two negative 3's when multiplied together will also get us a positive 9. So that when multiplied together, the 9 times the 9 here will give us a total of 81. So that'll be the first part of our final answer, is just that positive 81. The rest is going to come from taking that 4th power and multiplying or distributing it out also to the x to the 7th, we're going to multiply or distribute those two exponents, which will get us an x to the 28th. So that's our final answer. Let's take a look at D. In problem D, we've got AB raised to the 6th power. So if we raise, when we got parentheses, we have to remember that that means I'm going to raise everything inside to the 6th power. So I'll have an a to the 6th power and a b to the 6th power. And that's it. As long as I'm raising everything inside to the 6th power, we're all set.